Hello, everybody. I'm Leonid Korelshtein, VP of Research and Development in Piping System Research and Engineering Company. And I'm happy to participate in this event. And first of all, I would like to tell you about our joint experience of usage C3D kernel in our software products. But first of all, several words about our company. So our development team has more than 50 years history, first in different industry institutes and then as a separate private firm, company. The software already have more than 3,000 active users. The key focus of this software is engineering analysis for piping, plant, industrial safety. And we try to use in our software the best-in-class modern methods, algorithms, and libraries, and embedded knowledge from industry experts in combination with user-friendly interface and flexible licensing and CAD integration. On international market, we are known under the brand PAS. So in our group of companies, we have three companies. Piping System Research and Engineering, which is concentrated on software development, engineering and industrial safety, piping and equipment non-destructive diagnostic, and also applied scientific research, which are necessary to develop these activities. We also have our design company, which uses the same software as we develop and design different facilities, mostly in refining and petrochemical industries. And we also have our training center for offline and online training for our software and also some partner software. About our PAS software, it includes everything that is necessary for piping and equipment analysis, both fluid flow analysis and heat exchange analysis, and stress and stability analysis. And include four programs. It's other system for fluid flow, Start Pro for piping stress analysis, PAS Equip for equipment stress analysis, pressure vessels, columns, tanks, heat exchangers, and also PAS nozzle FM for nozzle shell junction stress and stability analysis. It's more than 50 years on the market, but on international market, we actively started only on 2018. But now we already are very active in many countries. You can see this on this map. So we have users on all continents. Now about our interaction with C3D. PSRE has licensed C3D in 2013, and it was one of the first C3D users. And C3D is now used in our PAS Equip and PAS Nozzle FM software, where it replaced our obsolete 3D kernel. And this is natural because in this software, we need to model the most complex geometry for different pressure vessels, nozzle shell junctions. And we use it for modeling complex pressure vessels, for mesh creation, for volume and mass properties calculation, and also to export our models to different CAD formats for transferring to different CAD software. This is done using C3D Modeler and C3D Converter. Now about this software itself. So PAS Equip is an analysis software for strength and stability calculation for horizontal, vertical, column pressure vessels, tanks, and different types of heat exchangers. And it contains a vast database of typical elements and materials, and provide different features for CAD integration. Here you can see some of our customers worldwide in oil, refining, chemical, petrochemical, oil and gas, thermal power, and other industries, which include European customers, South Korean customers, many American, many others. I'm sure you can find some companies which you, of course, know. So we have different national codes, international codes as ISME, European codes, API 650 for tanks, and some others, including large material database holding different codes, ASME, European, Chinese, and so on. And the philosophy is what you see is what you calculated. So you just see all details of our models with all internal structure, with all elements, with all structural elements, just in the model. And you can look at it in wireframe, in solid, in transparent view. What is more convenient for you? Well, like this, for example, you see all internal structure of these heat exchangers. There's some examples for model expert. For example, this is complex pressure vessel, and here is this model is exported into AutoCAD, and this is examples of exported of PAS-equip heat exchanger model into AutoCAD. Into SolidWorks using C3D Converter, and for example, here you can see that we have all details, and we can create some sections of the exported model in SolidWorks. There are some tools which we have. For example, for heat exchangers, we have a very powerful tool of tube sheet editing. We can define any complex tube sheet, and you will have just exact 3D representation of this tube sheet. We can define vertical tanks with all the elements, heads, nozzles, ladders, and so on. Structural detailing, foundation. And here some complex examples, nozzles on the nozzles, different type of nozzles, different type of supports. You can see different types of heat exchangers, complex equipment with several equipment pieces connected, columns with all structural elements, platforms, supports, and so on. And separately, there is a very interesting PAS nozzle FAM software, which is a special tool for solving problem with nozzle shell junctions, because it's necessary to quickly analyze them, to get allowable loads, to get stiffness flexibility for this junction, stress intensification factor, to make fatigue analysis. And this is only possible for, in general, by finite element method. So this tool provides a very easy way for ordinary engineer to do this. So all you need to do is just define geometry. What is your shell? What is your nozzle? How it's they are connected, and everything can be done automatically, including mesh generation, and you can control quality of the mesh automatically or manually. The analysis takes several minutes, and you immediately can look at everything in this nice post-processor, including all stresses, different components of stresses, the different combination of loads, and so on, and fully understand what's happening. And here are some more complex examples with interaction of several nozzles, or with flat box nozzle junctions, or with connection with several shells with different temperature. And here are the thermal stresses. And this pass nozzle FAM is also integrated both with pass equip, so you can immediately get all data of all nozzles of your vessel and analyze them. And you can also have two-side integration with our piping stress analysis software. So you can analyze any nozzles or any non-standard elements in the pipe, and the flexibility, the level of loads can automatically be returned in your piping stress analysis software. So all this, of course, can be done due to very effective use of C3D kernel for geometry modeling and for model conversion. Thank you.